Yeah. Hello students. Welcome to Akshara IIT Foundation classes. This is Gafar sir, your physics faculty. Let's start our session. In the last class, we have discussed that vector concept. That too, what is a vector and how do you represent the vectors, and some types of vectors have been given to you. So today also we'll do continuation of that part. So let's show that part. I'll show this is with a module. Please everyone look at here. So the module is, see the module look at here. This is the part we done in the last previous class. So here, so in the last class we represented the vectors. So representation of the vectors, what is this vector, and what is vector quantities, what is scalar quantities, what is tensor quantities. That part we did. How to express this physical quantity, how to express the vector, this part we did. So today we will learn some other extra information, that is nothing but types of vectors. Look into the types of vectors. Already I started the types of vectors. So the types of vector, the very first type is, see here, very first type is, now observe here, very first type, the very first type, look at here, this is equal vectors. Very first type is what? Equal vectors. Understand what is mean by this equal vectors? So here equal vectors are the vectors having same magnitude and acting in the same direction. So look at here, this is A is a vector, isn't it, and B is a vector, are acting in the same direction. So the direction is same. Since these two A and B are two vectors, are called equal vectors. That is the information related to equal vectors. Understand? How can you write in a mathematically these equal vectors? So here A bar is equal to B bar. A bar is equal to B bar. And one more important point here, children, that is these A bar and B bar must have the same nature. Same nature, what is the mean? What is the sense of same nature? The sense of same nature is nothing but, look at here, the sense of same nature, if A is a force, even B also what? Force. So that is the sense of what? Sense of same nature. And let me take one more example. If A is a displacement, then B also what? Displacement, isn't it? The B also what? Displacement. That is mean by the same nature. So equal vector means not only the magnitude and direction, though must have the same nature. That is meant by the equal vectors. I hope you have understood. The next one more here. The one more type of vectors are, look at here, like vectors. One more types of vectors are what? Like vectors. Look at the like vectors here. So here other type. So here like vectors or other concept, other type of vectors are nothing but like vectors. What is mean by the like vectors? Here like vectors means the two vectors having different magnitude but acting in the same direction. Two vectors acting different magnitude, and here next thing is what? Same direction. Acting with different magnitude, same direction. So what is this? Look at here. This A and this is B. This is vector A and this is vector B. These two vectors are acting in the same direction. The two vectors acting in the same direction, but observe that magnitude is different. How do you represent any vector with pictorially or diametrically? So with a straight line having arrow mark, that is known as a diagrammatical representation of vector. In that, arrow represent the direction, the length represent the magnitude. In this case, observe the length of the two vectors having different kada. So when different length meaning that different magnitude, but acting in the same direction. Since these two vectors known as what kind of vectors? Like vectors. Got my point? And here these two vectors may or may not be same nature. If this is a force, if this may be a what? Displacement, or else acceleration, something else, may or may not be the same nature. But when you are considering the equal vector, though must have the same nature. So coming to this part, they may or may not be the same nature, but different magnitude, same direction. Those known as what? Like vectors. Coming to the other part, the other part of the vector is nothing but, look at here, other part of the vectors, unlike vectors. So here other part of the vectors are unlike vectors. What is mean by the unlike vectors? Unlike vector means acting with same different magnitude in different direction. Here different direction is sensing that acting with opposite direction. So this is a vector and this is a B vector. This is acting in this direction, this is acting in this direction. Since these two vectors are nothing but unlike vectors. I hope you have understood, isn't it? And next, very important, these nature of the vectors are very important because if you know this vector notations, if you know this vector natures, if you know these types of vectors, we can easily solve kinematics problems. That is the reason we are explaining the topic vector here clearly, each and every point. So keep it in mind. And one more thing here. The one more thing is, one more important vector form is, look at here, negative vector. So one more important type of vector is what? Negative vector. What is this negative vector? So negative vector means it is a vectors acting with opposite direction with same magnitude. Vector acting with opposite direction with same magnitude. Look at here, this is a vector A and this is a vector B. Look at observe carefully the direction represented by the arrows kada. So this is arrows. So for this vector acting in right direction, but the vector B is acting opposite direction, isn't it? Since how can you write this mathematically? We can write mathematically, if A bar, if I consider as a positive direction, then obviously B bar is representing the what? Negative direction. But both having the magnitude is same. Keep it in mind. Magnitude is same, and also the nature also here same. Nature must be same, magnitude is same, but must act in opposite direction. These are known as what? Negative vectors. I'll give one more thing. For example, there are A vector acting this direction and B vector acting this direction. This is A vector, this is a B vector. Now let me write a negative vector of B. Negative vector of B, actually this is a positive of B. Negative vector of B must be, you must write in this direction. So that representing the negative vector of B. So negative vector of A we can write in this direction. This is representing negative vector of A. So that is how we can say, we can explain that what negative vectors, isn't it? I hope you have understood what I am explaining. Got clarity? And one more very important point here. The one more very important point is very important, that is known as unit vector. What is that? Unit vector. Very important this unit vector is. We are using this unit vector many times. Oftenly we are using this unit vector in the representation of any physical quantity. Let us discuss this. Here, what is mean by unit vector? First of all, let me know this first. That is nothing but, unit vector is nothing but, it is a vector having unit magnitude as well as direction is what? Unit, simply the vector, unit vector is a unit vector having unit magnitude. Having how much magnitude? Unit magnitude means 1. So see here, what is the purpose of this vector? This purpose of the vector is it will represent the direction. What is the purpose of this unit vector? It will represent the direction. How it will represent direction? See here how it is. First of all, how do you express the unit vector in a mathematically? For example, there is a vector A. There is a vector A. This is a vector A I am taking. If this is a vector A, its unit vector I required. We must find unit vector of this A. How do you find the unit vector of this A? Mathematically, generally vector represents what? Caps. Any vector represents with cap. A cap is equal to vector A and magnitude of vector A. Got my point? Vector A as well as magnitude of vector A will give the vector of unit vector. It will represent. This is a formula. Keep it. Remember. Now, if this is vector A, how can you express this vector A for representing the any physical quantity? Look at here. This is a representation of unit vector. But by using this unit vector, how you will represent a vector? Look at here. This is a formula showing the same. So A bar is a vector, isn't it? And this is a magnitude and this is a unit vector, which means that any physical quantity we can express as magnitude into unit vector. So I will write here vector is equal to magnitude into unit vector. So this is our important formula related to every situation. With this formula only we are using every time to represent the vector. So how can you represent the vector? Vector is equal to what? Magnitude of that particular vector and unit vector for that particular direction. So that way we will represent the unit vector. I hope you have understood, because this is very, very important. This is a very, very important relation. Better write down if possible. And now this note is not important for us right now. So let us go for another type of vector here. So I am taking this. So this is the formula expressing the unit vector, and with this unit vector, this is the formula representing the how to express the a physical quantity. Got my point? So now we don't have here, we do not require this note here. That is extra information for us. So if possible, you can read. Next, one more very important here, zero vector. It is also very important. Zero vector. Zero vector means, this also called null vector actually. This also called what? Null vector. How can you define this zero vector? Zero vector means zero only. Zero vector means what? Zero only. But what is this meaning? Zero vector meaning, null vector meaning. Zero vector means zero. But how can you define this? See, we can define in a simple manner. Zero vector means having zero magnitude. Having zero magnitude. Before we learn unit vector. Unit vector means having unit magnitude is known as unit vector. And here zero vector means having zero magnitude and having direction is undetermined. No direction. We cannot represent the direction. That is known as zero vector. Zero vector means magnitude is zero. The direction is undetermined. We cannot predict the direction. That is kind of vector is known as what? Zero vector. Is it possibility is there zero vector? Yes, it is possibility. We have a possibility of zero vector. For example, two forces are acting in the object. Simultaneously two forces are acting. For example, this is a pen. If I taking this is a pen, in this direction one force is acting, in this direction one force is acting. Thus these two forces are, if it is same, how much is the resultant force? How much is the net force? Net force is 0, right? So that net force 0 we will consider as a 0 vector simply. So that way we can say the 0 vector. Or else let us take one more example. So here a object is started a point A, and again it is covering some distance and reaching to the point A again after some time. But how much is the displacement here? Displacement becomes 0. So which means it is showing that 0 vector, because displacement is a vector quantity. I hope you have understood. Now coming to the another, this co-initial, co-terminal is not important. Okay, this is not our level, just given that information for you, better read it. And coming to the collinear vectors. What is this collinear vectors? The collinear vector means vector acting parallel to a straight line. For example, here we have drawn a straight line. For example, here we have drawn a straight line. We have a straight line. Any vector passing parallel to that, then we can say that particular vector as collinear vector of this straight line. That way we can define the vector collinear vector. And coming to the some properties they mentioned. Some properties mentioned for the 0 vector, because 0 vector also very important. The properties mentioned here. Look at here the properties. Some properties they mentioned. So first property is what? If add with any vector to the 0, you will get the same vector. That is nothing but we are adding a vector to 0 vector. The magnitude, without changing the magnitude, we will get same as it is. So here also 3 vectors we have taken. One is a vector, one is b vector, one is 0 vector. Then result is, tell me, obviously a vector plus b vector. And coming to the here, 2 vectors acting with the same magnitude, acting with 0, then we'll get a 0 vector. So something multiplied, something magnitude is applied to the 0 vector, so then also you will get a 0 vector. These are some examples where we are using the 0 vectors. I hope you are getting my points, isn't it? Yeah. Next, this proper vector also not required. So next, one more important type of vector is coplanar vectors. This is also very right. Coplanar vectors. This coplanar vector also very important here. So what is this coplanar vectors? Any vectors acting in the same plane. Vectors acting in the same plane are known as coplanar vectors. I will show with a diagram. Look at the diagram here. The diagram is, see, this is the diagram. So here how many vectors we have? This is a vector, this is b vector, this is c vector. These vector acting in this plane, since these a, b, c will call as coplanar. It is magnitude is different, direction is different, doesn't matter. But if they are acting in the same plane, the vectors will call as coplanar vectors. Same thing opposite to this. What is this opposite to this? The vectors acting in different planes, the vectors is known as non-coplanar vectors. That is the definition here. Look at here the definition. So this is the way. See here the definition here. Non-coplanar vectors. What does it mean by non-coplanar vectors? Acting in different magnitude, in different planes, and different directions are known as what? Non-coplanar vectors. If they are acting different direction, different magnitude, but in the same plane, those are called coplanar vectors. If they act different magnitude, different direction, in different plane, those are called non-coplanar vectors. I hope you understood this. And coming to this, next topic is very important, it is angle between the vectors. Very important. Angle between the vectors is very important. Angle between the vectors is very important here. How we will consider the angle between the vectors? See here, when you are taking the angle between the vectors, where you will take the angle between the vectors is very important. Let me take two vectors A and B. If you are taking A and B, you must take the angle between the vectors when, if the two tails are coincide, interior angle you must take the angle between the vectors. If the two vectors tail and head join, the exterior angle you must take the angle between the vectors. Look at here how it is. Look at here, this is a vector A and vector B. This is called head, this is called head of the second vector. And now this is the tails joining of the two vectors. When the two tails joining, the inner angle you must consider as angle between the vectors. Now we are talking about a Cartesian coordinate system. What is this Cartesian coordinate system? Uses of this Cartesian coordinate system is very important instead of definition. So the uses of this Cartesian coordinate system is, we will use this Cartesian coordinate system as a reference frame. Understand? I can give an example here. You know movies. In the movies you have, you know, RR. RR means background score. Background music we will call as RR. How the RR or background score of the music is how much important for the movies nowadays, the same way the Cartesian coordinate system also act like the same way. Understand how RR or background music is giving the information to the movie. Similar manner, this Cartesian coordinate also will give the information to you knowingly, unknowingly. Got my point? How the information is given by the background music knowingly, unknowingly, in the same manner this Cartesian coordinate also will give the information to you knowingly, unknowingly. Got my point? But what is this? This Cartesian coordinate consists of x-axis, y-axis and z-axis, and the intersection of these and these three axes acting perpendicular to each other. Understand? So here, look at here. This is a x-axis. This is look at here. This is x-axis. This is x-axis, and this is y-axis, and this is z-axis. They are acting. The angle between them is mutually perpendicular to each other. Means this is 90. This is 90. Even this is also 90. The intersection point of this three axis is known as origin. What is that? Three axis is known as what? Origin. Here this is called origin. But how can you represent the coordinates of the origin here? This is called 0, 0, 0. So this way, this coordinate system or Cartesian coordinate system will help you. Next thing is another vector form here. So another vector form here. The other vector form is orthogonal vectors here. Another vector form is what? Orthogonal vector. What is this orthogonal vector? Orthogonal vector means simply the vectors acting with 90 degrees. The vector acting with 90 degrees is known as orthogonal vectors. If the vectors acting with 90 degrees, if the magnitude is 0, then we can call that is orthogonal unit vectors. So here orthogonal unit vectors along x direction, y direction, z direction are, see here along x direction, look at here, this is we are talking about now orthogonal unit vectors, which means the vectors acting x direction, y direction, z direction, because x, y, z are mutually perpendicular. Whatever the vector in acting x direction, The orthogonal vector we can consider as I cap. This is y direction is we can consider as j cap, and this is k direction is k cap. This is the way orthogonal unit vectors are nothing but I, j, k simply, without if you take cap or doesn't, without taking the cap, it doesn't matter. These I, j, k are representing the unit vectors commonly. Okay, what is the purpose of these I, j, k? As these are unit vectors, you know unit vectors will give the direction for any physical quantity, which means these I, j, k are helping you to show the direction of the any physical quantity. Got my point? We have examples, don't get worried, you will come to know. Next one is, see, this is a way along x direction the unit vector is I cap, along y direction is j cap, along k direction is z direction is k cap. This is the way we will use. Now here we have given an example also. Look at the example. We have a vector, magnitude is how much? 3 units. We have a vector here. What is the magnitude of the vector here? 3 units. And if this vector acting along x direction, then how do you use this unit vector to represent the vector? You know vector, already I told you, vector is equal to magnitude, isn't it, into direction, and unit vector kada, magnitude into unit vector. This is a formula we know already. See here, we are talking about vector A. Let us take a vector A here. Vector A, how much is the magnitude? Already we mentioned as 3 units, since this is 3 units. But it is acting which direction? It is acting x direction. But in x direction unit vector is I, since this is become what? Vector A as 3 into I, 3a simply. Similar way, look at here, a vector magnitude 6 along negative x direction. Then how do you represent? We represent as minus 6i, because x is a vector here. What is the magnitude of this x vector? 6, but it is acting negative x axis. To represent that negative x axis, we must give for the unit vector as negative sign. So, but along x direction vector, unit vector is I cap. So this is about vectors. Next, coming to the position vector. So here coming to the very important position vector here. Then how do you use this position vector? How do you express this position vector? Look at here. What is this position vector and how do you write this position vector? Look at here. Position vector, it is a vector shows the status or position of any vector. Okay, what is the definition of position vector? Position vector is a vector shows state or position of anything with respect to the reference frame. You know reference frame means Cartesian coordinate system generally we are using. Got my point? And it has x and y direction, z also. Let us take, I'll show a position of any point with the help of a reference frame and with the help of unit vector. Let us take here, it is a point. This is a point. Here we have a point here. If this is a point, this coordinates of this point is x comma, y comma, z. What is the meaning of these coordinates x comma, y comma, z? Here x means this point have x displacement in x direction as x, y displacement is y, z displacement is z. Then how do you represent this point name is, let us give P. Then I want position vector of this P. We can write the position vector of P as this way. this is we can write as R bar. So OP, if you consider OP bar is equal to, let me write as R bar. The R bar is representing that xi, because this is having some x distance or x units in x direction. So that is why xi, because I is a unit vector in x direction, plus it having some units, y units in y direction. So this is yj. Similar way, it having some z units in z direction, since it is become zk. So this is the way we will represent the unit vector. Got my point? So I hope you have understood the unit vectors and vectors, everything. So I'll tell important the types of vector is, first one is position vector, this is what, and next one is unit vector. So these two are very, very important. Many times repeatedly we'll use this unit vector and position vector. So children, I hope you have understood what I explained today. So next topic we'll see in the next class. For today I'll stop the session. Bye bye.